So when you see these two groupings that you got your brackets here and your parentheses inside, start the innermost one and then work your way out. Okay? So there's nothing I can do with the y minus 1. So I'm going to distribute that negative 2. So I get 6, and then 3y, and then that's minus 2y plus 2. And then minus 2 plus 7y. And then inside here now that parentheses is gone, inside these grouping symbols, the brackets, I can combine the like terms and get 1y. Okay? And now I distribute the 6. So I'm distributing a second time. So don't distribute the 6 off the bat. Work from the inside out. Okay? So we had 6y plus 12 minus 2 plus the 7y. Now here's where some kids will make a mistake. You know, you're thinking about solving for y, getting y by itself. So you'll say, well, I got to put this 7 and this 6 together, so you'll subtract 7. Did you move it to the other side? No. So if you're not moving it to the other side, you're doing what it says. You're not doing the opposite. Remember, you go to the opposite side of the equation, then you do the opposite, right? So these are like terms, put them together. So that's 13y and 10. Now it looks more like something we're used to messing with, right? Working with. Any questions to this point? What we did is just simplify that whole left side. The right side was just 0. And now I'm going to subtract 10 because I'm going to the opposite side now. Do the opposite of addition. And then I'm taking that 13 to the opposite side. It's 13 times y, so to move it to the opposite side, I have to divide. So that's my answer, negative 10/13. And it's okay to get a fraction or a decimal. It's not always going to be a nice whole number for you. Does that make sense? Any questions? Okay, so that's what we were working on for the most part last night, was solving those types. And then we had some of the absolute value ones that, remember, there's 2 problems on the absolute value ones. But most of you remembered that. All right, so number 3 on page 85 was negative 4. Number 6 was 33/7. That'd be 4.8 or 9 if you did the decimal. Number 9 is 2/9. I think that's 0.2 repeating. That's a decimal. Number 12 is 10. Number 15 is 9. Number 18 is 68/11, which is about 6.2, I would say, decimal-wise. 21 is 95/18, which is, 5.3 or 4. Let's stop right there. Any questions up to 21? You'd like to see anyone? Okay, I'd like to go over 12, just to make sure we understand on the fraction one. Let's make sure we keep our phones put away. Some of you guys are letting that distract you. Okay, so here's our problem. We got some fractions in. Yesterday we talked about eliminating the fractions first thing so we don't have to worry about. How do we do that? What do we do to get rid of those fractions? Right, the common denominator, which would be what? 4. If you wanted to go 2 times 4 and get 8, that'd be okay too, it would work. But 4 is the least common denominator. And what do we do with it? Yeah, we multiply. All the terms in the equation, you multiply by 4, so you're not changing it. If you want to do a couple of them, you're changing it. All right? So you just go 4 times 1 is 4, divided by 2 would be 2. And 4 times 7 is 28. 4 times 1 is 4, divided by 4 would be 1, so that's a negative 1 n. 4 times 19 is 76, divided by 2 is 38. So now it looks like that. It looks like it's a lot easier, doesn't it? So that's what I would do if I were you with the fractions. Multiply by a common denominator. It doesn't have to be the least common, but a common denominator. So if you just want to multiply the 2 denominators, you can do that. But you'll get rid of your fractions that way. And then we're going to combine like terms here. Simplify 3x. Oh, sorry, not 3x. 1x plus 28 equals 38. And then we'll subtract 28 because we're going to the opposite other side. Yeah. Okay? So that was how I would do 12. If you look at 21, you had a fraction equal a fraction. We call that a proportion. You can just cross multiply. Does anybody want to see that one? 21? Yeah. Yeah, you end up distributing. We got 40 minus 3x over 5 equals 6x plus 7 over 8. So if you have one fraction equal one fraction, I would just cross multiply. So 8, whoa. We go 8 times 40 minus 30x equals 5 times 6x plus 7. So this is how we would multiply. We're going to have to distribute, like, what was you, Kyle, saying that right? Mm-hmm. 8 times 40 is 320, and 8 times negative 3x is negative 24x, and 5 times 6x is 30x, and 5 times 7 is 35. So I want to subtract 30x to get the x's on the left. I'm going to also take the 320 to the right. I'm just doing 2 steps at once. So I subtract the 320. So that's gone, and that's gone. I get a negative 54x on the left, and a negative 285. Is that right? And then divide by negative 54. So that should give us whatever answer I told you. What was it? 95/18. What's that dividing by 3? I think that reduces. Oh, positive. 2 negatives make it positive. 3 goes into 54 18 times, and 3 goes into 285 95 times. Okay. Anything else up to 21?
Can you rephrase that again, please? Can I go?
What part? At the end?
Like, why did you write it like twice? Like that? As you distributed it? Why did you write that twice? No, like, it's.
Oh,
yeah.
what I did here?
Yeah.
I did 2 steps. I took the 30 x over to get the x's together. And then I took the 320 over here to get it with 35. So I just did 2 steps at one time instead of one at a time. Anything else? Okay. Then 24 was an identity. If you, 3 was our common denominator. If we multiplied everything by 3, we'd get 6x plus 1 equals 6x plus 1. So we see it's an identity, that means there's all real numbers, anything would work. For 27, if I multiply both sides by 4, the whole equation, I get 4x plus 8 equals 4x plus 32. And then those 4 x's, when I get them together, they cancel out, so you get 8 equals 32, which is a false statement, a contradiction. No solution to that. Number 30, I would distribute the 3 and then distribute the 4. And you'll get 12x minus 32 on both sides, so you see it's an identity, all real numbers. And then 33 was 4 and negative 4, 36 was 11 and 5, 39 was 2 and negative 8, 42 was 21 and negative 27, and 45 was 12 and negative 18. I want to look at 45. Just to remind you guys that there's 2 problems here when it's absolute value. And before we write the 2 problems, we got to get that absolute value part isolated or alone. Some of you at this point right away tried to write the 2 problems. Okay? So you want to move the 4 over, and you want to move that 2 over. Do not distribute the 2. Just take it over. So now I have the absolute value part isolated or alone. Now I can write my 2 problems. And they're real easy to write, it's x plus 3 for both. Only thing that changes is the 15, and the second one becomes negative 15. And then we'll just add 3, subtract 3 in both of them. So negative 18 is one answer, and 12 is the other. So if I went back to the original problem and put 12 in for x or negative 18 in for x, we'll get 34. Okay? Remember, absolute value, 2 problems, 2 answers. Any others that you would like me to go over that maybe I didn't go over? Okay. Today, we're doing similar stuff, but we have more letters than numbers we're going to be looking at. But we're still solving equations. Okay, so it says solve v equals 1/3 pi r squared h for h. What's that asking you to do? Chris? Yeah, isolate the h. So whatever comes after the word for, that's the letter they want you to get isolated or by itself. Okay? So there's only one number up there, it's 1/3. Okay? So we just talked about it. Let's use the common denominator to get rid of that fraction, right? What is the common denominator? 3, the only one, right? So multiply everything by 3. So 3 times v is 3v. And what's 3 times a third? 1. So it's just 1 pi r squared h. We don't usually write the 1. So that's what it looks like now. We got rid of that fraction. Okay? This is all multiplication. I want to isolate the h. I want to get it alone. So that means I got to move the pi r squared to the opposite side. So how do I move it? Divide, yeah. Same rules we've been using. So even though it's a lot of variables, letters, the procedure is the same. So h is alone because all that canceled, right? And we just have this fraction, 3v over pi r squared. There's no number answer we're getting because we don't know what v is or pi. We do know what pi is, but r. We don't know what v or r is. So we just write it out as a little equation. Okay? Solving for a variable. Same rules. You're moving to the opposite side of the equation, which you'll be doing, you do the opposite. Okay, now this next one's tricky. That one was pretty easy. This one's kind of tricky. So S equals 2 times the quantity WH plus LW plus HL for W. They want us to get W isolated. Okay? So when you got multiple W's, since you're looking for W, or if we were solving for L, we'd have multiple L's. We usually have to distribute or something. Okay? And sometimes you won't. Sometimes you might just have this. Okay? So keep the W's together on one side, get everything else on the other side. But since there's 2 is in front, we're going to distribute to help us do that. I can get that quick down. Okay. So I got my S equals 2WH. I want to make these L's capital just so they don't look like ones. 2LW and 2HL. Just distribute it to 2. Okay? Again, my goal is to get W alone. There's 2 W's on the right, so let's just work on getting anything that's not got a W with it on the other side. So this is addition. To move to the opposite side, do subtraction, right? Do the opposite. So these are not like terms, so just write it. S minus 2HL. Any questions so far? Okay, now here's where you got to think a little bit. I'm supposed to get W by itself. 1 W, right? But there's 2 of them here. So what we need to do is think of that as a GCF. What do I do with that W? We call that what? What's that word we did a lot of the last couple weeks ago? Factoring, right? We want to factor out that W. So it goes from 2 W's to 1. And what is 2WH divided by W? 2H. And what's 2LW divided by W? 2L. You guys can handle that, right? Now it looks like that. So remember, when I factor out the W, factoring means you're looking for what times what gives you that, right? That's what factors are. The factors are 15 or 3 times 5 or 1 times 15, right? So this is W times this quantity. How do I move that quantity over there now? Since it's W times that. You would divide, yeah. Going to the opposite side, do the opposite. So we're going to divide by that 2H plus 2L. So those 2 cancel. W's by itself. It equals this fraction. Looks kind of weird, but that's okay. The procedure is the same as what you always do when you have numbers, when you're solving an equation. Okay? So we'll be solving. Actually, we only got 2 problems like that to do. Then we're going to have 4 word problems. Okay? So let's look at a couple word problems for practice. Any questions up to this point? You guys okay? You staying awake for me? Some of you had a full belly at lunch. Now you're feeling a little sleepy. The golden tones putting you to sleep, eh? Sorry. Should I start talking? What the hell? No, probably not. Couldn't do it anymore. All right, so Here's one of the types of problems, word problems. This is the word problem. It says, one of the best known paintings is Mona Lisa by Leonardo da Vinci. It is on display at some French name in Paris, the Louvre, something like that. Maybe you art people could help me with that. The length or height of this rectangular shaped painting is 24 centimeters more than its width. The perimeter of the painting is 260 centimeters. Find the width and length of the painting. All right? So it's a rectangle. So just draw a rectangle. You don't have to actually draw the Mona Lisa. All right? It says that the length is 24 centimeters more than the width. So did they tell us how wide it was? No. So what do we got to put down for the width? W, X, doesn't matter. You can use whatever letter you want. W is fine. It says, talks about the length in terms of the width. It says this is 24 centimeters more than this. So how would I write that? What if this was 10 centimeters? What would this be? It's 24 centimeters more than that. 34. What'd you do? You add it. So if this is W, you're going to write W plus 24. You're going to add it. Right? Does that make sense? Because we don't know what the width is. Now, if we got a rectangle, what do we know about this width? It's the same as the other one, right? And this length? The same as the other one. Does that make sense for the picture? There's another sentence in there. It said the perimeter of this painting is 260 centimeters. What is perimeter? What's that mean? The distance or total distance around it, right? The outside. Well, if you total something, what do? Add, subtract, multiply, divide. When you total stuff. You add, don't you? So that's what we're going to do. We're going to add up the four sides equals our perimeter. That's all. So W plus W plus W plus W, those are like terms. It's 4W. 24 plus 24 are like terms. That's 48. Equals our perimeter of 260. So there's our equation for this problem. Does that make sense? So you will have one or two perimeter problems. What if it said area? Would I add up the sides? You would multiply. Okay, so maybe you'll have, instead of perimeter, an area. Okay? So then you just solve this. Subtract 48, divide by 4. Okay, so what's that telling me? Yeah, width is 53 centimeters. And they said, the question is, what are the dimensions of your painting? Are we done? No, we got to add the 24 also, right? We got to get that 77. Okay, make sure you answer the question then, once you're done. Okay? Not just get a value for X and go on. Make sure you answer what they're asking you to answer. All right, the last type, and this type will be on the quiz. There'll probably be some type of perimeter or area problem on your quiz. But I know there's one, I remember that there is one of these. And again, this is just your book page numbers and where it's at, but you don't have to go there. I'll just read it to you. It's called an investment problem. So it says an accountant invests part of a $6,000 bonus. So information, he's got $6,000 he wants to invest. Part of it in a 5% simple interest account, with some of it in 5%, and the remainder, the rest of the money, in an 8.5% investment. Both of them are simple interest investments. It says, together the investments earn $370. Okay, so they're going to make some money, interest, just sitting in there. One's getting 5% interest, the other one's getting 8.5%, but the total earned after 1 year is $370. Okay, so the question is, find the amount invested at each rate. So you got to figure out how much of the $6,000 was in here and how much of the $6,000 was in there. That's what we're looking for. All right. So since I don't know how much he put in at 5%, I can make it X dollars, right? Because I don't know. How much is left over for this amount? Jamie, what if I put $2,000 at 5%? How much was left over for the 8.5? 4,000. How'd you get that? You're so smart. How'd you know it was 4,000? Yeah, you do. What'd you do to get it? If that was a 2,000, right away you knew that was 4,000. Because what must be true about these two? We give you 6,000. So you went 6,000 minus 2,000 in your head real quick, didn't you? All right. So if it's X dollars, I do the same thing. Subtract this from what? 6,000. Okay. Since we don't know how much that is, one of them's X, the other one is the total minus X. And it doesn't matter. If you make that the X, then this one's the 6,000 minus X. It doesn't matter. But one of them's X, one's the total minus X, no matter what your total is. All right? The total minus X, not X minus the total. Some kids flip that. Come Tuesday. All right? To find interest, earned. Simple interest. You just multiply the amount of money times the interest rate. So how do I multiply X times 5%? Do I just put 5 in the percent symbol times X? No. What do we do with the 5%? We make it what? A decimal point, 0.05, yeah. So the amount we made at the 5% would be 0.05x. And the amount we make at 8.5% is what? 0.085 times 6,000 minus X. To get the total earned, what am I going to do with those two answers? When we say total, we do? Add. And we know the total is 370. So there's my equation for this. Then you just solve the equation. Questions on the setup? The one's always what? X. One's always the total minus X. Change the percents to decimals, multiply them, add them, equals the interest earned. Okay? So when I do this, finish it up, I distribute, that's 510 minus 0.085x. Subtract the 510. And put those together, that's a negative 0.035. X, that's a negative 140. Okay? Now, when I start seeing negatives in a problem like this, remember, I'm looking for, what am I looking for here? I'm looking for an amount of what? How much was invested at each one? That's an amount of money. Will I want negative answers?
No.
No. So if I get a negative answer, I should say to myself, I did something wrong, right? But what happens when I divide a negative by a negative? We'll get a positive, so we'll be okay. So what is that? Is that 4,000, I think? Did someone do it already? 4,000? So, $4,000 at 5%. How much at 8.5%? How much is left? 2,000. 6,000 minus 4,000. Okay, so we answered the question. How much was invested at each rate? Okay? So there is a problem like that on the quiz Friday. All right? So you'll have one of those tonight for homework too, I imagine. There's only 6 problems for homework, because I know some of these take a little bit of time. Don't want to give you too much. There you go. Again, you guys have been doing a good job. Keep up the good work. Make sure we submit. Some of us are getting it done but not submitting, so get it submitted in. Hopefully the internet's working decently for you.
When are we gonna get the graphic calculator, or is that not gonna,
When you gonna need it?
are we gonna be able to have it on the laptop?
We have not been able to find, we've been looking, but we haven't been able to find one that we can download. They kind of took that away from us. They weren't making their money off of their calculator, so they're saying, we need them to start buying them again instead of downloading them. All right, there's a few kids who found them. Download, a free download or a $5 download for their phone. So maybe
No,
you could look for that.
Feel like spending $120 on the calculator.
Why did you have one like?
Oh, because we had it on the computer.
Yeah.
Who's that? Microphone. I can still like it.
Is this, karaoke? Karaoke. I saw it, yeah.
Have you read it?
No.
Yeah. Yeah, I'm really good on the song. No. Yeah. No, just like
We might have pretty much as well.
Yeah, I'd rather have my phone. I'd rather- So would you rather not see it, or would you,
You guys outside today or in the gym? Did you go out?
Oh, green.
I really like off.